Okay. So in projectile motion, so basically this is a case where we have motion with constant acceleration. Okay. So
Yes.
the particle will be projected with a velocity u, which makes an angle theta, let's say with the horizontal. This is a standard projectile case. Okay. So first we'll see the
Yes.
standard case and then we'll go to non-standard case. Okay. And then we will see that it covers a trajectory like this. The equation of this path will be parabolic. Okay. So
Yes.
this is a standard projectile, but even if you have a non-standard projectile, like in some of the cases, it will be like this is the tower of a building, and then you are throwing a ball, so it will get dropped like this, right?
Yeah.
So these are non-standard projectile cases. Okay, but whatever it is, the method for solving these problems will remain same. And how do you solve this?
Okay.
So you have to write the x motion, and you have to write the y motion separately. Okay, as we discussed in the last class. Yeah.
Yes.
So x motion, y motion. Now you know that these are the motion with constant acceleration. So we will apply those formula. But before we apply those formula, let us write these things. What are these things? Is that x will be what? Vx will be what? Okay. Then what will be x
Yes.
naught? X naught is the initial x coordinate. What is the final x coordinate? Okay, when the particle comes here. Similarly, we'll try to write uy and vy and y naught and yf. Okay, so tell me,
Yes.
if the particle is projected from origin, and this is, let's say, r comma 0, where r is the horizontal range. Okay, so where this is your
Yes, sir.
horizontal range. Okay, so tell me what will be ux. What can we write ux as?
Ux. U
X
cos
component of
theta.
initial velocity.
Yes. U cos theta.
U cos theta. Okay, and similarly uy will be u sin theta. Yeah.
Yes.
What will be vx? So let us we'll find out vx and vy. Okay, what will be x naught?
Yes. 0.
0. Y naught will be also 0. What will be
Yes.
x final? X final, if we want to find
R.
instant when it hits here, then x final is r and y final is 0. Okay, so what is
Yes.
ti? Ti is the initial time stamp. Let's call it as 0, and tf is your, let's call this as time of flight, t.
Yes.
Okay, so this moment is your ti equal to 0, and this moment is tf is equal to t. Yeah, so
Yes.
then let us write the equations. So for x motion, we have these equations. What are the equations? The equations are vx equal to ux plus ax into tf minus ti. This is a motion with constant acceleration, right? And we have x is equal to x naught plus ux into tf minus ti plus half ax into tf minus ti square, right? So if you put these things, then what will you get? Let's say if you put your this thing in the second formula, then you will get r is equal to x naught is 0, ux is u cos theta, time of flight plus, and what is ax? Yeah, you have to write here ax also. What is ax and what is ay?
Ay is minus g.
Ay is minus g, very good. And ax is?
0.
Ax is 0. Why? Because the particle throughout its motion, particle is subjected under gravity. Okay, force of gravity.
Yes.
So from this equation, what will you get? You will get u cos theta minus half g t square. Okay. Similarly, you will write the equation for y motion, and if you write the equation for y motion, so let's say if I write vy is equal to uy plus ay into tf minus ti, or we write y is equal to y naught plus uy into tf minus ti plus half ay into tf minus ti whole square. You have to apply this formula in this form. Okay, so when the particle reaches here, what is the y final? Y final is 0, y initial was 0, uy is equal to u sin theta into t minus half gt square. Okay, so from equation 2 you will get t as 2u sin theta by g.
Yes.
This is called time of flight.
Yes.
Okay, so why I'm showing you this derivation is not because you will be asked this derivation. You have to proceed in this way for any non-standard projectile also. Is that clear? And if you put this
Yes.
value of time of flight in equation 1, you will get r as 2, you will get r as u square sine 2 theta by g. Is it clear? So these are the formula for time of flight and the horizontal range. This is called time of flight. Okay, time of flight, and this is called horizontal range.
Yes.
Horizontal range. Is it clear?
Yes.
Okay. And let's say somebody is asking what is the maximum height. So this is the point where it reaches the maximum height. So this point's coordinate will be, and in this standard case, this maximum height is exactly symmetric. Okay. So this point's coordinate will be r by 2 comma h. And when it happens at t equal to t by 2. Okay. So again, we can use this formula and let us put y coordinate, final y coordinate will be h, initial y coordinate is 0, uy will be u sine theta. Tf in this case is the t by 2 because we want to find the y coordinate at that instant. So t by 2 minus 0 minus half g into t by 2 whole square. Did you understand this?
Yes.
Okay. So if you solve this, you will get h as u square sine square theta by 2g. So this is the formula for maximum height. Is it clear?
Yes, sir.
Okay. One more thing you can see that if you want to find the velocity, so Vx is equal to Ux plus Ax into Tf minus Ti, but Ax is 0, so this term will be always 0. That means Vx is always equal to Ux. So the horizontal component of velocity always remains same. Okay. So Vx is always equal to Ux, and that is U cos theta. So what does that mean? Is the horizontal component of velocity always remains same. Okay. Yeah. And if you have to find the Vy, let's say for the generic formula for Vy will be Uy plus Ay into Tf minus Ti. And if you put Tf as T by 2, that means at maximum height, you will get Vy as 0. Vy is 0 at T is equal to T by 2. That means at maximum height, it won't have any y component of velocity. And that is why this is maximum height. Okay. So another way of solving maximum height is that you can find the timestamp where the vertical component of velocity will vanish. Is that clear? Because if the vertical component has vanished, then only it will stop moving upward. Okay. And that's where it will reach the maximum.
Yes.
Is that clear? Yeah.
Yes.
So Vx is always constant and Vy varies, and at maximum height, Vy is equal to 0. Okay. So you got the formula for time of flight. You got the formula for horizontal range. You got the formula for maximum height. You know how to calculate the velocity at any instant by because Vx is always constant and Vy you can find out by this formula. For example, if you have to find the Vy at maximum height, it will be 0. Is that clear? If somebody is asking what will the velocity of impact? Velocity of impact means what will be the velocity here? So how do we calculate that? So we know that the Vx is always constant. So we know no need to find out Vx again. We know Vx is always constant. So Vx will be u cos theta here. Okay. What we need to find out is just this Vy. We need to find Vy, this component of velocity. And this component of velocity, how will you find Vy? So Vy here will be nothing but at t equal to t, at the time of flight, what will be the velocity, right? Are you getting me? So how do you find this Vy? So this Vy you can find by applying the formula that Vy is equal to Uy plus Ay into Tf minus Ti, right?
Yes.
What is Uy? Uy is your u sine theta, Ay is minus g into t is your 2u sine theta by g. That is the time of flight at this instant, right?
Yes.
So if you do that, you will get minus u sine theta. So that means the velocity of impact is same as the velocity of projection. Only thing is that the y component has changed its direction. Okay. So at the point of projection, it had Vx in this direction and Vy in this direction. At the point of impact, it has Vy in this direction and Vx in this direction. Any doubt?
Yes.
The velocity of projection is equal to the velocity of impact in magnitude. Okay. But direction wise, it will be just y component will be just get reversed.
Yes.
Any doubt till here?
No, sir.
Okay.
Yes, yes.
Now one more derivation is like what will be the path of the equation of path? Can I delete the middle part, middle portion?
Yes, sir.
Okay. So let's say if you have to find the equation of trajectory, so that you can find by replacing x and y. Okay. So let's say at any point you will write x coordinate as x naught plus ux into tf minus ti. Okay, plus half ax
Yes.
into tf minus ti square. But you know ax is 0, so this term will be 0 because ax is 0. So you will get x as initial x coordinate is 0 and ux is u cos theta, and let's say at any time t, tf is my any time t, and initial time instant is 0. So you will get x is equal to u cos theta t. This is your equation 3. Okay, now your y
Yes.
coordinate equation is y equal to y naught plus uy into tf minus ti plus half into ay into tf minus ti whole square. So y naught is 0, y final is y because at any y we want. So y naught is 0 plus uy is u sine theta, tf is your anytime t, ti is 0 minus half g t square. Okay, so what we'll do is that from equation 3 we will substitute t in equation 4. Okay, so when you do that,
Yes.
you will get u sine theta into t, you will get as x divided by u cos theta minus half g, and t square you will put x square divided by u square cos square theta. Is that clear? And that gives you the equation of trajectory, and that becomes u gets cancelled, right? So x tan theta, so this will become x tan theta minus half g sec square theta, right? Half gx square divided by u square cos square theta or sec square theta if you bring it to the numerator. Is that clear? So this is the equation of trajectory, and this is a parabola. If you have done maths, you can recognize that y, it is a format of y equal to b naught minus kx square, which is a parabola. Okay, and since it is negative here, so it is an inverted parabola, and that is why the path is like this. Is that clear? This is the equation of trajectory. Hello? What happened?
It is connected, sir.
Okay. Yeah, you understood? Any doubt in this?
No, sir. In this.
Okay. So these are the standard projectile. Okay. But let's say, can I delete this page?
Yes.
Okay.
No, wait a minute. Yes, sir. Done.
Okay. Let's say if you have a non-standard projectile questions. So for example, in SC Verma, there are a lot of questions like that. So let's just take a example. Let's say you are standing on a tower. Okay. You are standing on a tower like this. Okay. And let's say two of your friends are standing and one of you is projecting it with a velocity of 5 meters per second, making an angle of theta equal to 30 degrees. Okay, this is u1. Let's call this as u1, and one of your friend is throwing it like this. Okay, this is, let's call u2, and this is also theta equal to 30 degrees.
Yes.
Okay, and so basically you have to find out this height of the tower is given. So let's say the height of the tower is h, which is maybe, let's say for example 10 meter. We'll solve in terms of the unknowns first. Okay, so you have to find out where will be the first ball, okay, when the second ball hits the ground. So find the height of, first question is find the height of ball one when ball 2 hits ground, when ball 2 hits ground. Okay, and second question is find the height of ball 2 when ball 1 reaches maximum height, when ball 1 reaches maximum height. Just an example. Okay, how will you solve these kind of questions? So let's say we start with the first part. So part A. So you have to find out the height of ball 1 when ball 2 hits ground. Yeah. How will you,
Yes.
what will be your approach?
First, we can find the time taken by ball 2 to hit the ground.
Yeah. So how will you find that? So let's say first analyze the motion of ball 2. So ball 2's motion. Okay. So how will you find the time of flight? So again, you have to go by X motion, Y motion. Okay. So ball 2's X motion and Y motion. Okay. So first, before you do anything, no, you first fix your coordinate axis. Don't change it. So let's say if I fix my coordinate axis at the ground level. Okay. So this is my X axis and Y axis. This is X axis, Y axis. So this coordinate is 0, 0. Okay. So tell me, let's say, so your initial moment starts here when you projected both this ball. Okay. And your, for the first part, my final moment is when it hits the ground. So this is, let's say this ball goes like this. Yeah. So this ball goes like this and it hits here. So this is the moment t equal to tf. Is it clear? Let's call this as t, capital T. Okay. So what will be the x naught? What will be y naught? You have to tell me what will be xf. You have to tell me what will be, sorry, x motion, y motion separately you have to write. Okay. So what will be x naught? What will be xf? Okay. Ax is anyway 0 always in this case. Yeah. And here what will be y naught and what will be yf? And what is ay? Tell me fast.
Y naught is 10.
Y
YF
naught is
0.
10. So I can write h. Let's do it in terms of unknown. What is y final?
0.
Y final is 0. Very good. What is ay?
AY is minus G.
Minus g. X naught is 0. X final is, let's say, let's say this is r. So r comma 0.
Yes.
Okay. So this is r.
So R.
Is it clear? So we have to find the time of flight, right? So basically we can write this equation. So we can write yf is equal to yi plus uy into tf minus ti plus half ay into tf minus ti whole square. So ui you have not written, right? So tell me what is ui here in this case for ball 2?
2, 5.
Fast.
U sin theta. U2 sin theta.
U2 sine theta 2, right? If it is called theta 1, this is theta 2. So U2 sine theta 2. U2 sine theta 2. Is it correct or wrong? Is it correct? What is your positive y-axis? Which direction? Upward. But this U2 sine theta will be downward, right? So you have to put a negative.
Yes, sir.
Is it clear?
Oh, yeah. Yes.
Yeah. So don't do that mistake. So yi is your this thing, right? Yi is your y naught basically. So h plus uy is minus u2 sine theta 2. Okay. Into tf is your t. Ti is 0 minus half g t square, right? And yf is your 0 because when it hits the ground, y coordinate becomes 0. Is that clear? So from here you get t. So solve this equation and get t. This is a quadratic equation in t. Okay. So your equation will become half gt square plus u2 sine theta 2 into t minus h is equal to 0. So solve this quadratic and you will get time t. Get t.
Yes.
Is that clear?
Yes.
Yeah. Maybe one value of t you will have to discard based on maybe it will come negative or it will come before it impacts. Okay. So once you solve this equation, you'll get to know. Now, once you get this t, so this is the t you wanted. Now, what is asking? Find the height of ball 1. So say now the same analysis you have to do for ball 1. So for ball 1, what will you write? Can I erase the right part?
Yes, sir. Done.
Did you understand? Any doubt till here?
No, sir.
Okay, so let us now again write ball 1 motion. So you have to always proceed by this method. Okay, any projectile question you can do. So ball 1 motion. So this is your x motion again, and this is your y motion. Okay. So for
Yes,
ball
sir.
one, what will you write? Tell me what will be ux. Ax is anyway, you know, ti. What will be ti? What will be, what is asking? Find the height of ball f. So tf. Okay. And then
Yes.
what will be xi and what will be xf? For y motion, again you have to write all this. So what is uy, what is ay, what is ti? Tf is anyway common. So what is yi and what is yf? Tell me, what is ux for ball one?
Ux is u1 cos theta,
U1 cos theta 1. What will be uy?
sin theta,
Uy
u1
will
sin.
be u1 sin theta 1. Okay. What will be
Yes.
ax? 0. What is ay? Minus g. Ti is 0. What is tf?
Tf is u square,
Tf is what
2ux.
we calculated in the first part, that time t.
Yes.
Okay, because it is asking at that
Okay.
time where it is. Okay.
Ah, yeah.
What is
Yes.
xi? Xi is 0. And what is xf? I don't know. What is yi?
I is h,
Yi is h and yf is what you have to calculate.
0.
No, you have to calculate where it is. That
Oh,
is what
yeah.
it is asking. What is the height? Okay.
Yes, yes.
So it is asking the y coordinate. So let us apply this formula. So yf is equal to yi plus uy into tf minus ti plus half into ay into tf minus ti whole square. So what is yi? Yi is h. What is ui? Ui is u1 sine theta 1. Tf is your t minus 0 minus half g into t square. Put t from equation, put t from part 1, right? That will give you the
Yes, yes.
y coordinate, and that will be the
Yes.
height. Y coordinate, any, let's say it is somewhere here, right? Somewhere here. Let's say it is
Yeah.
here. And that is the y coordinate. Is that clear? This is the y coordinate.
Yes, sir.
This point's coordinate will be x comma y. Okay. Similarly, you can try to do
Yes, sir.
part 2. Okay. So in part 2, find the height of the ball 2 and ball 1 reaches maximum height. So when ball 1
Yes.
reaches maximum height, so always remember at maximum height, the uy component of velocity. So u1y, okay, y component of velocity will be 0. Okay, that is how you find
Yes, sir.
maximum height. So at maximum
Yes.
height, the y component of velocity ceases to exist. Any doubt?
No, sir.
So this is how you will proceed for any non-standard parabolic question. There are a lot of questions in SC Verma. Okay, so you
Yes.
can try all those projectile questions in SC Verma. I don't have SC
Yes.
Verma book, but you can see, I think after 20 or something, you will have all the questions from SC Verma. Okay, yeah.
Yes.
So you can try all that. So one thing I was going to tell you is there is simple case of motion under gravity. That is the simplest case. Okay. So motion under gravity is there will not be any x motion, only y motion. Okay. So
Yes.
this I should have taught you before projectile, but this is the very simplest case. Okay. In this kind of question,
Yes.
what will be there is that, let's say you are sitting on the top of a tower. Okay. And you are throwing a ball, but it is making only vertical motion. Okay. It is only like this.
Yes.
So you don't have to
Yes.
write the x motion. So for example, if it is
Yeah.
projected with a velocity of 5 meters per second, then it will tell that how much distance it will cover. So the question is how much distance the ball will cover in 4th second. Ball will cover in 4th second. In 4th second. How will you do this kind of question? Let's say height of the building is something h. Okay. In 4th second, how much it will cover? Like this kind of question. 4th second means between t equal to 3 to t equal to 4. Okay. In this second, how much it has covered? This is what you have to find. Is it clear? So how will you do this kind of question? So first you have to find at t equal to 3 second, what is the y coordinate? So find y coordinate at t equal to 3 second. Okay.
And then find it for 4 seconds and then subtract.
Yeah, and then just subtract. So find y is equal to y coordinate at t equal to 4 second and just subtract. Is it clear? That will give you. And how will you find t equal to at 3 seconds? So just apply this formula. This is motion under gravity with constant acceleration. So y is equal to y naught plus uy into tf minus ti plus half into ay into tf minus ti. Is that clear? So
Yes.
here y naught will be, let's say, h, uy will be complete uy because there is no x component. So 5 into t minus half gt square. Put t equal to 4 seconds, you will get that distance. Put t equal to 3 seconds, you will get again y3 and y4 and take the difference. Is that,
Yes.
is that clear? So if you put t equal
Yes.
to 3 seconds, you will get y is equal to h plus 15 minus half. If you take g as 10, so into 9. So how much you will get? You will get 15 minus 10 by 2 is 45. So 15 minus 45 is h minus 30.
H minus 30.
So that means it has come down. Okay, so it has come down somewhere here. Yeah,
Yes.
that is why it is less than h. And similarly, you
Yes.
put t equal to 4 seconds, you will get y is equal to h plus 20 minus half into 10 into 16. So you'll get h plus 20 minus 80, right? So
80. Yes.
20 minus
60.
h minus 60. So basically,
Yes.
this is your h minus 30, this is h minus 60. So this difference, right?
Yes.
So this difference is 60 minus 30, so 30 meter. So this is the 30 meter, it has traveled 30 meter downward, right, in 4th second.
Yes.
Is that clear? So no need to worry
Yes,
about any question. That question you starts from here. Okay, so you have to just draw the projectile, write x motion equation, write y motion equation. But first thing is that you have to fix your axis. Okay, so fix your axis
Yes.
first, x axis and y axis, and write all those conditions: ux, uy, ax, ay, vu, vx,
Yes.
vy, everything, and then proceed. Is that clear? You have to just
Yes.
remember this formula. But in all these cases, you must be seeing that these formulas we are applying because it is motion with constant acceleration. Do not apply this formula in any case, okay? Because people just remember s equal to ut plus half a t square, v equal to ut, u plus at. Do not remember in that way. Remember in this way: y is equal to y naught plus uy into tf minus ti plus half ay into tf minus ti.
Yes.
Is that clear?
Yes.
Any questions?
No,
Okay,
sir.
so try all HC Verma questions. HC Verma questions. Okay, I think from 20, you have the HC Verma book. Can you see from where it starts? I think from question number 20 it starts. So from question number 20 till last 3 questions you leave, and then you can do all the projectile questions.
It starts from 23, sir.
23, okay. So do from 23 and it ends where? 48 or something? I think last
No, sir,
page.
it ends at
Last page questions are not projectile. So just before the last
no,
page.
sir. 47th. Oh, no, 44th, sir. 44th.
Yeah, so you have almost 21 questions. Okay, so try to do these
Yes.
questions. Yeah, that will give you a good confidence on projectile. Is it clear?
Yes.
Any doubt?
No, sir.
Okay, and since we are doing projectile, let us do one more case of projectile, which is called projectile on an incline. Okay, so let us do
Yes.
projectile on an incline. Okay, so
Yes.
this is also same case, yeah, but only difference is the projectile will be projected on an inclined plane like this. So this is your incline. Okay, this is the cross section of an incline. Incline will actually look like this. Okay, so incline will be like this, right? So this is the cross section of an incline. Yeah. So it can be any generic motion. So let us consider the simplest case when the ball is projected from here like this. Okay, and let's say it is projected with a velocity u. Okay, the incline angle is alpha. Alpha is the angle of incline, and the angle of projection with the inclined plane is theta. So this is your theta, and this velocity is u. Is it clear? So before you start your problem solving, first thing is that you have to fix your axis. So my axis, I will fix origin here. I will take x-axis like this, and I will take y-axis like this. Okay, why? Because this will help me. Okay, because if I take along the incline, it is better. So I'll take along the incline as x-axis and perpendicular to the incline as y-axis.
Yes.
Is it clear? Now what will happen?
Yes.
The projectile will basically, you will see that the motion is like this. It will go and hit somewhere here. Okay. Yeah.
Yes.
So yeah, before you do that, first let us try to understand the gravity. So let's say at any point of time when it is here, the gravity is acting downward, right? Gravity is still downward.
Yes.
Gravity is still downward. Is that clear? So this is the acceleration due
Yes.
to gravity. So if you take the component of gravity towards your chosen x and y axis, okay? So this is your x axis, right? This is your x axis and this is your y axis.
Yes.
Okay. So if you take your component along chosen x and y axis, so see, one thing you can always remember, if the angle between two lines is theta, then the angle between perpendicular to them will be also theta. So if the angle between these two is theta, then the angle between perpendicular to them. So this is the perpendicular to the horizontal and this is the perpendicular to the incline. So the angle between perpendicular to them will be also theta. So this angle will be also theta. Okay, this is a very common thing that you can use always. So I know that this angle is alpha. The angle of the incline is alpha. So the angle between perpendicular to each of them. So this is the angle, this is the perpendicular to the incline and this is perpendicular to the horizontal. So this angle will be also alpha.
Yes.
Is that clear?
Yes, sir.
Okay. So now the component of gravity in this, what can I write AX as? Tell me. What can I write AX as and what can I write AY as? So you have to take the component of gravity along x-axis.
Yes, sir.
So what will be that?
AY is G cos theta.
AY will be G, not theta, alpha, right? This is the angle alpha. This is your Y axis.
G cos alpha.
This is your Y axis. Y axis is upward. Okay. So AY will be what? G?
Minus G.
Minus G cos alpha, because Y axis is your upward. And what will be AX?
Sin alpha.
Minus G sin alpha. Okay.
Yes.
So always you can remember this basically. So whenever you have a gravity, then towards the incline it is G sin alpha and perpendicular to the incline it is G cos alpha with a negative sign because you have chosen your axis in this way. Is that clear?
Yes.
Yeah. Now it is same way. So basically this is origin. Let's say if they're asking what is the horizontal range. So this is your r comma 0. Okay. If r is this, if r is this distance, right? If this distance is r, then that will be r comma 0. Now you can write again same way x motion and y motion. Okay. Only thing that will change is in the previous case your ax was always 0, right? In this case ax will not be 0. Okay. So let's say if I write ux, so ux will be u cos theta. If you have to write uy, you will write u sin theta. Okay. Ti is, let's say Ti is 0 in this case and Tf is equal to time of flight if I want here. Tf is equal to T. Yeah. And then you have to write Ax as minus G sin alpha. And here you have to write Ay as minus G cos alpha. Any doubt? Yeah.
No, sir.
And then you have to write the coordinates. So basically x0 is 0. Y0 is also 0. X final is, let's say, r, and y final is again 0, right? And now you apply the equation. So if I have to find the horizontal range, let us first find the time. So how will you find the time? So you can write y final is equal to y initial plus uy into tf minus ti plus half ay into tf minus ti whole square. So ui is 0. Yf is also 0, yi is also 0, uy is your u sin theta, tf is your t, capital T, tf, ti is 0 minus half, ay is your g cos alpha into t square. Is it clear? So when you solve this, what will you get? You will get t as 2u sin theta divided by g cos alpha.
Yes.
Okay, so it is the same formula that you obtained. Only thing is that in place of g, it is g cos alpha. Is it clear?
Yes.
Yeah.
Yes.
Now again, you can write the x motion equation and you can substitute this t, you will get r. Yeah.
Yes.
So if you put the x motion equation, I will not do that. So x final is equal to x initial plus ux into again tf minus ti plus half into ax into tf minus ti whole square. So what is xi? Xi is again 0. What is your ux? Your ux is u cos theta. Okay. Tf is this t that you have found minus half. This term will not vanish. In the standard projectile, this term was vanishing because ax was 0. Here ax is not 0. Minus half g sine alpha into t square. Put this t here, you will get r. No need to remember.
Yes.
Is that clear? One thing in this kind of question, they will ask that what is the maximum height? Okay, can I delete this?
Yes, sir.
Okay, so same thing if they ask you find the maximum height. Okay, find maximum height in this case. Maximum height. Okay, always remember height term is always used with respect to ground level, not with respect to incline level. Okay, so height means even if they do not mention, if they can mention that find the maximum height with respect to ground, then it is obvious. Or if they do not mention, then height is always with respect to ground. Okay, understood?
Yes, sir.
So let's say when the part with respect to ground, where is the maximum height? I think this point is the maximum height, right?
Yes, sir.
This point is the maximum height with respect to ground. Okay, with respect to incline, this is the maximum height. With respect to incline, this is the maximum height, but with respect to ground, it further goes, right? So this is the maximum. Now it comes down. So this is the maximum height point with respect to ground. Let us call that as h. Is it clear?
Yes.
Yeah. So this is a tricky part. How do you find this point where it will attain maximum height?
Yes.
Okay. So how will you find that? Any idea? So if I draw this, let us say that if I show this thing again, any idea, anything you have done before that you can apply to find the maximum height? So basically this is the incline. Okay, so the maximum height point will be, it will be somewhere here, right? So this point will be the maximum height.
Yes, sir.
Okay, so this point is your max. You have to find out this point. Is it clear? So what will happen
Yes,
at this point? What will happen at this point? So the velocity will be, see, if it is maximum height with respect to ground, then the velocity has to be in this direction here. Because with respect to ground, perpendicular to ground is this, right? So it does not have any velocity in this direction. That's why it is maximum height with respect to ground. So the velocity direction must be in this, along this. Is it clear?
Yes.
Yeah, so net velocity must be along your original x-axis. So let's say, suppose if you, but your axis is x and y is like this. Your x and y axis are like this, right?
Yes, sir.
So how will you find what condition you will impose so that your velocity is like this? This velocity vy is not 0 because your y axis is like this. It still has a component. Are you getting me? So your
Sir,
chosen axis is
can
like
you
this.
share your screen again?
Why you are not able to see?
Yeah, there's a cut in the page. So
Okay.
everything is shifted weird.
Okay, is it okay now? Better?
Yes, sir. That's fine.
Yeah. So what I was telling you is that this is your x-axis and y-axis. Okay. So your Vy is of course not 0 because there is a component of V along y-axis. Yeah. So how will you find this velocity? So in order to find this velocity, yeah, what you can do is that that let's call the original axis as x prime and y prime. Suppose my original axis, this was your x prime. Let's give it a different color. Okay. So let us call the original axis as x0 and y0. This is my original axis. Okay.
Yes.
So this axis is my x0, y0. Okay. So your V component of V along your original y-axis has to be 0. Are you
Yes,
getting
sir.
me? So can
Yes,
you
sir.
tell me one thing? If you have this kind of situation anywhere, no? So you know that the velocity component along y naught has to be 0. This is what you want to do. Okay.
Yes,
So
sir.
what you will do now in this kind of situation, you write your V vector and take dot product with a unit vector along y naught. Along y naught. Is it clear?
Yes, sir.
But this
Yes.
unit vector must be expressed in terms of your new x and y axis.
Yes.
Are you getting me? So your
Yes.
new x and y axis is like this. So basically your x and y axis is like this. Okay. This is your x axis and y axis. So tell me this unit vector, like a unit vector along your original y axis was this, right? Your original y
Yes,
axis
sir.
is this. So how will you write this unit vector in terms of x and y? Unit vector means its magnitude is 1. So you have a vector of magnitude 1 directed vertically, and
Yes, sir.
you have to express that vector in terms of your I cap and j cap. So along this axis you have I cap. Along this axis you have I cap, and along this axis you have j cap. So you have to express this unit vector, the original j cap vector which was there along y axis, in terms of I cap and j cap. So how will you write?
Yes, sir.
So see, in order to do this, you know that this angle is alpha, right? This angle is alpha. If
Yes,
this
sir.
angle is alpha, then perpendicular to this is this line, and perpendicular to this is this line. So this angle is also alpha.
Yes.
Clear? Now any vector you can write component. So what component of 1 along x-axis will be what? This is the component, right? So this is 90 minus alpha. So it will be 1 cos 90 minus alpha into
Yes.
I cap plus 1 cos alpha into j cap. So what it comes, cos 90 minus alpha is sin alpha. So sin alpha I cap plus cos alpha j cap. This is the unit vector along y naught. Did you understand this or not?
Yes, sir.
Any
I got
doubt?
it. Yes. No, sir.
No?
No.
Okay. Now what is v vector? V vector you can write vx I cap plus vy j cap. Yeah?
Yes.
So vx I cap plus vy j cap, you take dot product with this unit vector sin alpha I cap plus cos alpha j cap, and this must be 0. Why? Because your vy component has to be 0, because that is the maximum height.
Yes.
Is it clear?
Yes. Yeah.
So if you take the dot product, what you will get? You will get vx sin alpha I cap is 0 plus vy
Yes.
cos alpha is equal to 0. Right? V dot
Yes.
this is 0. So this is your vx sin alpha plus vy cos alpha is equal to 0. This is the condition for at maximum height vx and vy will be related like this. So at maximum height vx and vy will be related like this. So this means what? This means your vx is equal to how much? Vy cot alpha minus vy cot alpha.
Yes, sir.
Okay. Any doubt?
No, sir.
Okay. Now you can write vx and vy and you can use this equation, right? So if what will be the equation for vx? So vx equation will be, I can write the vx equation as ux plus ax into tf minus ti, right? What is your ux?
Yes.
Your ux you have already written, that is your u cos theta. So I can write
Yes.
u cos theta. Ax is your minus g sin alpha, minus g sin alpha.
Yes.
TF you don't know, so you can just write T minus 0. This is your Vx. Is that clear? Similarly, you can write
Yes.
Vy as Uy plus Ay into Tf minus Ti. Yeah. So Vy is
Yes.
your what? What is your Vy? Vy is your let it be Vy. Uy is your u sin theta. Ay is your minus g cos alpha into T. Is that clear?
Yes.
Use these 3 equations and you can find out the time T. Okay, so eliminate T from first and 2 and use that in 3. You will get your time. And once you get your
Yes.
time, then you put in the y coordinate equation, you'll get the height. Is that clear?
Yes.
Any doubt?
No, sir.
Okay, so don't, this is little bit lengthy, but don't worry. The basic concept is Vy will be 0 at maximum height. Okay,
Yes.
so how will you do Vy as 0? Vy naught is 0. Y naught is a unit vector along your original y axis. So write that unit vector in terms of your new unit vectors. The new unit vectors are I cap and j cap in this direction. And then I took the
Yes.
dot product that gave me the height. Is that clear?
Yes.
If they're asking you
Yes.
the height with respect to incline, then it is easy. Then it is actually Vy is equal to 0. In this case, Vy is 0. Right? Here Vy will be 0.
Yes.
Here Vy will not be 0. Are you getting me?
Yes.
This is the maximum height
Yes.
with respect to incline. So with respect to incline, it will not travel further like this. Right? So this
Yes,
part will not be there. So at this point, Vy is 0. So just use y equation formula, put 0, you will get the time. Time will be u sine theta by g cos alpha. And then you put y equation and you'll put that time t, you'll get the height. Is it clear?
Yes.
So this height is the height with respect to incline, but this is the height with respect to ground. And if they do not mention it explicitly, and if they ask about maximum height, you have to find the maximum height with respect to ground only. Is that clear?
Yes.
And that time Vy will not be 0, but Vy with respect to the original axis will be 0. So keep that in mind. Any doubt?
No, sir.
So this is your projectile on incline. No need to remember any formula and all. Okay. Just
Yes, sir.
remember how do you solve. So just you have to quickly do this. You have to quickly write the x motion, y motion, write all the parameters which is given in the question, and then apply these 3 equations and try to manipulate those 3 equations to get your answer.
Yes.
Any doubt or not? Tell me frankly.
No, sir.
Okay. So this is your projectile motion. But you have to
Yes.
do a lot of question. Okay. So once you
Yeah.
do a lot of questions, so you can now do in Irodov, there are 1 or 2 questions on projectile on an incline. So you can do that question also. Okay.
Yes.
Yeah.
Yeah.
And so basically in kinematics, what is pending now is why it is hanging. Okay. So let me just give you a brief. Okay. So in kinematics, what are the topics? Are you able to see my screen?
Yes, sir.
Okay. I don't know. It is hanging for me. So kinematics, I'll have to stop and share it. Okay. So kinematics topic. So first thing that I taught you is your basic kinematic parameters. Okay. So first thing that we did is kinematics parameter.
Yes.
Okay. And there were 3 methods to do kinematics parameters. So first method I taught you was the vector method, right? And
Yes.
we did some illustrations on that. And the second
Yes.
method was the coordinate method, right?
Yes.
Coordinate method. And the one more method is there, which is called natural method. Natural method. This method we will do in next class. Okay. And
Yes.
then we did your special case of kinematics parameter, that is motion with constant acceleration. So motion with constant acceleration. Okay. One special
Yes.
case of motion with constant acceleration was projectile motion. So motion under, first we did motion under gravity, basically when there is only vertical motion. So motion
Yes.
under gravity, vertical motion.
Yes.
And the next topic what we did is a projectile motion. Okay, which is also motion under motion with constant acceleration in 2 dimensions. So we did projectile
Yes.
motion. And the third one more special case of projectile motion, projectile along an incline. Projectile along an incline.
Yes.
Okay. So up to this we have done. Yeah.
Yeah.
Now, what is it? What are the topics? Just want to give you a brief overview. What are the topics that we'll be doing? So after this, we'll do natural method of kinematics.
Yes.
So which will cover your circular motion, natural method of kinematics. So this will cover circular motion. This will cover
Yes.
circular motion. Okay, and radius of curvature concept and all that. Okay, and once we do
Yes.
natural motion, then we have to do two more topics, which is the graphs. Okay, Vx versus Ax, or if Vx graph is given, Ax graph you have to plot like that. Okay, graphs in kinematics.
Yes.
Graphs in kinematics. Okay, we'll do. This is also very important topic. They ask a lot of questions on this. Okay. And
Yes.
after graphs in kinematics, one last topic is your relative motion. Okay, so relative motion. So in relative motion, there are one or two very famous problems, which is called riverboat problem. We'll do riverboat problem. Okay, or man and rain, this problem. Okay, all are same. Okay. And in this, one more thing that is called as velocity of approach. Velocity of approach. So these three concepts.
Yes.
Is it clear?
Yes.
And I think this will complete your kinematics. So basically, we are done with the first topic. We are done with the second topic. In the next class, we will start this. By this topic, by these two topics, what should be covered is, by this topic, try to finish HC Verma. HC Verma full you can do, because except relative motion question, except relative motion and graph question, okay, which will be first few.
Yes.
Except relative motion and graphs. Okay.
Yes.
Solve all questions of HCV. Solve questions of HCV. Okay. And solve Irodov, whatever is given in the class. Solve Irodov.
Yes.
Selected questions that I have given in the class, in the
Yes.
last class. Okay. Yeah.
Yes.
So basically, next class, before I start natural method, you ask me question from HC Verma. So next class will be HC Verma problem discussion. Is it clear?
Yes.
So first try to
Yes.
complete the projectile questions, which is 23rd to 48, I think 46.
Yes.
And then come back to the first question, first few questions, first to 20. I think in first to 20, there are a lot of questions from graphs. So you can leave that, but at least try to do from 23 to 46.
Yes.
Is it clear? And do all the Irodov questions. Any doubts so far?
No, sir.
Okay. So yeah. Any feedback? Anything you want to tell?
No, sir.
You understood everything, no? Getting at this
Yes.
space is okay, right? This space is okay.
Yes. Yes.
Okay. Okay, then I'll see you then in the next class. Okay. Yeah.
Yes. Thank you, sir.